So, hello everyone. You did a pretty good job with my last name. I'm surprised. So, as she was saying, my name is Martín GONTOVNIKAS. That's with the Spanish and Argentine accent, maybe. And today I'm going to talk to you about JSON Web Tokens and how we can do authentication with them instead of cookies. So, oh wow, now. So, the title is like, I don't know, I just put this kind of title so that the talks get accepted. It's like, death to cookies, long life JSON Web Tokens. It sounds awesome. So we're in the tech world, so my Twitter handle is mgonto. If you want to follow me and increase my ego, I would be like greatly appreciated about it. And I am basically a software developer from Buenos Aires, Argentina. And I work at Auth0. That's another thing that is like really hard to pronounce for me. Auth0 is basically a SaaS that helps you with authentication and authorization. So if you want to have authentication made easy for you in your app for like Active Directory, social stuff, or username and password, you can use it. If you're interested, you can talk to me afterwards. But I used to be there mostly coding JavaScript all day long. So this was me. I love this GIF. It's like, bah. But right now, I work as a developer advocate. I don't work with Al Pacino. I love Al Pacino. And a lot of people ask me, like, what does a developer advocate do? And this is me when I was 17 in a karaoke. So it's kind of the same. I'm still in stage. But instead of singing like shit, I'm speaking about technology, which I know a little bit more. And I speak about that in different places. And in order to be able to speak, of course, you gotta still code. So let's actually start with the talk. But before starting with the talk, well, I have one question. It's unrelated with anything. Hands up, who is like a morning person? OK. It's not that many. I'm glad because I'm not a morning person. And all conferences make me wake up at 7:30 a.m. So basically, this is me every morning. And I want you guys to be listening to what I say. So basically, what I thought is to put flashy lights to wake you up. So let's look at them for 5 seconds. OK? And the other thing that I was thinking about is doing T-shirt time. I always wanted to throw T-shirts, and everybody loves T-shirts. And Auth0 would love you, because if you use them, you would be walking promotion for us. So why not, right? It's free for everyone. So let's try to throw one. I've been practicing in the room. It's like from across the bed. It's like, phew. So a little more flashy lights. And I think we're awake. So now we can start. So how does the web work right now? So let's imagine that I'm going to, I don't know, I bought the Apple Watch, for example. I actually put it in Do Not Disturb mode so that it doesn't vibrate all the time. And I bought it on apple.com. So how would it work for me to be able to buy the Apple Watch? The first thing that we have always is a browser and a server. And every time that I want to buy something, I basically have to log in. So I sit down, I enter my username and password, and I click on Login. That will send a post request to apple.com server, sending the username and the password. The server will receive them. It will go to the database, check if the user exists, check if the password match. And if everything is OK, it will create an object in the session. What is the session? The session is basically some in-memory storage, where it will have all of the users that are authenticated at a given point in time. So after they check that I exist, they will basically create these user objects in memory in here, and it will have an ID. And they will send back that ID to the browser. How do they send that ID to the browser? They basically use cookies. Cookies is something that is built in on the browser. So the browser will see that the response has this cookie. It will see that it's for apple.com, and it will basically save it in the browser. So now I want to buy something. So I click on buy. Whenever I click on buy, my browser is like really intelligent, because it says it's apple.com/buy. I have some cookie for apple.com, so let's send it. Maybe it's useful. I don't know. So it just sends it back to the server. And what the server will do, basically, is it will grab the cookie. From the cookie, it will get the user ID. It will check in the session. It will check in this in-memory storage if the user exists. And if it does, then it will go to the database and like take my money, because I'm buying the Apple Watch. So that's all it will do. So it's basically getting, as I was saying, the cookie. It will getting the user ID from there, and then getting the user object and just taking my money and sending a response to the server. And this is how most of the web works right now. And that actually used to work really well. But there's a problem now, because if we are here, we are in the browser day here, it's because we're starting to do a lot of stuff in our browser and not everything in the server. And this model doesn't work that well with that. And there are a couple of reasons for that. First one, cookies don't play well with cores. So if you have ever created a single-page app, you have an application in app.com and the server in server.com. And if you want the browser to be able to call something from app.com to server.com, you need to use cores. And if you're using cookies with cores, you probably saw the same Stack Overflow result as me, because the first thing we do when there's a problem is Google. And the problem is that cores is not easy to configure, because it needs to send the options request before any request. And if you're using cookies, it's even harder, because you need to set like with credentials and need to respond something special in the options. So it's like really hard to make it work with cores. Another thing is that cookies actually require stateful servers. So what does it mean to be stateful or stateless? Something in like 2 words, something that is stateless is that given an X request, I always get the same Y response, because there's no side effect. When I'm using cookies, there is a side effect, because I have this in-memory storage that is called a session, and that session is state, and I'm checking versus that to see if the user is authenticated. So let's imagine a case where I'm getting bigger and bigger, and I have 3 servers now. So I log in with server 1. Server 1 saves the user in the session. Then I get the response, and now I click on buy, and that goes to the server number 3. The server number 3 will say, hey, this user is not logged in. And that's because this session is only on the server number 1. And that doesn't work, because this depends on state. And HTTP is actually a stateless protocol, because given an X request, it always returns Y, and it doesn't know about past requests. It just knows about the current one. So making this authentication with cookies and session is basically a hack on top of how this works, on top of how HTTP works. To make this work with 3 servers, what we do is we have like a Redis or a Mongo session that is shared between all of the servers, or we have something that is called sticky session, which means that if I logged in against server number 1, then all of my requests will go against server number 1. And as I was saying, APIs should be stateless. If you go to Facebook, Twitter, Google, whatever API, they are all stateless, and none of them uses cookies, because if something is stateless, it means that it's easier to debug and easier to maintain. Because if I only depend on a request in this X to test something and to know what's going on, it's really easy to test against that and to set an environment for that. If I depend on another state, on other things that are around this function, and not only on the request, on the input that I have, that means that it's going to be much more work for me. And Google, Facebook, and Twitter don't want to lose their money. Probably anybody who does an API doesn't want to lose their money and spend a lot of time on debugging, maintaining, etc. So basically, that's why you should make your APIs stateless. And with cookies, even though it can be done, most people don't do it, because most frameworks by default use this in-memory session. And the other thing, which is the hardest to explain, is that cookies don't flow. Every time we have more and more servers that we depend upon. So it's not only my single-page app calling a server, it's also my single-page app calling a server. That server then calls another server, and that another server calls another server. And what I want is that if I'm doing an authenticated request, I want that identity to flow between all of those servers and all of those requests. And if I want to do that, cookies work well between browser and server, because it's built in the browser how cookies work. But when I want to do a server-to-server call, cookies don't work out that well, because I need to use an API or a framework to call this API. And most of them don't integrate cookies that well, because it's easier to do it somehow else. So cookies are really hard to make them flow throughout all of my different servers. So what I want to propose to you is basically a better approach, which is token-based authentication based on JSON Web Tokens. So let me first show you what a JSON Web Token is. Ta-da! Basically, here on the left, we have the token. And you might say, that's like any SHA, like any token. But in reality, it's not, because what you see on the right is exactly the same on the left. The most important part of the token is this blue part, and it's the payload. And the payload is whatever information you want. So you can put like user ID, username, first name, last name, or anything like that. So in here, if I like change this, like Martin, you will see that while I type, the token changes. And that's because what you see on blue is actually a base64 URL encoded. That's a lot of words. Base64 URL encoded of the part on the right. And this JSON Web Token is actually a spec from the IETF that went final like 4 or 5 months ago. And besides this payload, which can be anything, we also have this header. This header has some specifications that we need to follow. In this case, all important thing is that the type is a JSON Web Token, and the algorithm, in this case, is HMAC 256. This algorithm that we specify here is what will make our token secure. So how does it work? We do base64 URL encoded of the header. We add a period. We do base64 URL encoded of the payload. And then through all of this, we run this algorithm to get a SHA based on a secret. So let's say that my secret will be, hey, shoot, I like the Beatles. So now I got this signature, which is based on the secret, which is only known by my server, and the payload and header that we have. So now let's actually copy and paste this in this other window that I have. And you can see that in here it says invalid signature. Because what it is doing is it's trying to validate this token with this secret that I put here. And it's not validating it because this signature was not created with that token. So in order to validate it, I need to write, hey, should. And now it says signature verified. Because it's doing the signature with this secret, this header, and this payload. And it's checking that the red part that got from the token is the same one as the red part, the signature, that it just created right now. So based on this, how does the web work now? How can we make it work now? Let's say, again, I'm buying an Apple Watch. So again, sitting, enter the username, enter the password, click on login, that will send a post to the server. But now the server first, of course, has to check if the user exists, the password match, blah, 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 blah. But now it doesn't have to save that user in memory storage, because it can actually put the user information of who is logged in inside the JSON Web Token. So it will basically create a JSON Web Token with a secret that only this server knows. And in there, it will put user ID, first name, last name, etc. And then just return that as part of the response to the browser. Now, the browser needs to save it somewhere, for example, in local storage. And then the next time it will do a request, we need to send the authorization header. And we will say authorization, better, and we will send the JSON Web Token that we got. So when I click on buy, it will send this authorization header, better token. And now the server doesn't need to actually check any in-memory state, in-memory storage. It just has to do 2 things. First one, it will check if this JSON Web Token was created by this server. For that, it will check that the signature was created with a secret that only this server knows. If that works, it will get the user ID, first name, last name, from the payload, from the content of this JSON Web Token. And once it has it, it will just look for me in the database and take my money. But the important thing is that this only depends on this request, because the request, this X that I'm getting, as I was saying before, has all that I need to identify the user. It has the JSON Web Tokens, which tells me that the user is authenticated. And inside that, I have the user information. So now I don't need any central storage. I don't need any database to save the environment of all the logged in users that exist right now. I just have it in every request. So that means that now my API is stateless, and I can just then return the response, and it will work. So the first time I saw it was like, yeah, sounds good, sounds cool, but how does it work? So first Tshirt time, why not, again? Let's try to the other side now. I'm so bad at this. I have a few others, so if you are like further ahead that first row, that's all I get, you can come later. So I will basically stop talking right now, and what we will do is we will see it in action. We will live code together. And when I mean together, it's because there's a warning, which means everything that I am like really typo friendly. I'm very good with typos, so probably things will break. It will happen something like this, or like this. I like bomb GIFs. That's why I put them. So let's actually do them. So let's kill the presentation. And let's actually start this. And let's see what we have right now. OK. So this is the sample that we have. As you can see, I should have been yesterday doing a talk on CSS because my abilities are impressive. But I'm not. So this is what we have. This is a home, and it has basically 2 buttons, which if I don't start the server won't work. And basically, the first one calls an API that doesn't require authentication, and the second one calls an API that does require authentication. So what do they return? The anonymous API returns any of a random 50 Chuck Norris phrases, because everybody loves Chuck Norris. So every time I click on it, I get 50. But since I'm ambitious, I want 100 Chuck Norris phrases, and the other 50 are behind authentication. So if I click on call secure API, it's saying no authorization header was found, because I'm not sending any token. So since we want more Chuck Norris phrases, we need to authenticate. And for that, we'll first implement the login. So let me show you the application. This is the application that I have. It's basically, this is the index HTML. And in this case, I'm not using any framework at all. I'm just using REPL for template, which I'll show in a second. But other than that, it's like vanilla JS. And I'm using page.js for routing. So let's actually first see the home. Sorry, let's first see the index.js. So when the app loads, it will require this boot. And this boot, all it will do is it will just require other things. So for now, it requires the home. And the home has this, whenever you go to the page, which is root, this one, it will just render this home view, this is the JS with all the methods. This call API is the one that we're using. And this is the HTML. So what we need to implement now is the login. So if we go to the sign-in folder, and we come here, you will see first that the HTML is already created. Because even though it's Bootstrap, I suck at Bootstrap as well, so I had to make it before. And this is my very complicated CSS. I just with 40%. I'm a genius, I know. So now, let's actually implement this. The first thing that we want to do is implement the route. So for that, let's come here to index.js. And we'll do something that most programmers love, which is copy-paste. So let's come here and let's copy-paste. Then let's say that this is the sign-in view. We will require the sign-in. And then in this case, the URL will be sign-in. And that's it. That was easy, right? Now let's go to the more complicated part, which is the view. Again, copy, paste. We're good at this. So, oh, I actually messed it up. See, I already messed it up. This has to be in the index.js. Now let's copy again. So if we come here, we copy, we paste. Now what we are having is the HTML will be signin.html. And then the website will be called signin. So now we just have to implement it. So let's see what we have so far. In the HTML, we basically have an input type text for username, one for password, and the button to submit. So what we want is to, when the user clicks on submit, we want to log him in. So let's say that whenever this is clicked, we will actually do, oh, it changed my keyboard. Sorry. I don't know why it happened. But I have a Latin American keyboard. So if it changes for me, it doesn't work. Now it works. So we will do this.login. And then whenever the user tries to log in, I want to get the username and the password. So let's come here and let's say that this will be the username and this other input type text will be the password. I'm using this ref to be able to get these values, basically. So now all I need to implement is this login method. So if we come here, we can say sign in.prototype.login, and this will be a function. See, I'm very typo friendly. Let's first prevent default. And then all we are going to do now is just call our API. So for that, we'll do an Ajax call. And the URL will be HTTP localhost 3001 sessions create. In this case, we'll do a post. We will send some JSON. And the data that we will send is basically the username and password. So the username would be this.ref.username.value. This is the reference to the input type text. And the password will be this.ref.password.value. And once we have this, then we just need to process both the success and the error cases. So this is the success case, and this is the error case. If there's an error, let's just alert it. So alert error.response text. And if it works, in the response, I'm getting the JSON Web Token in a field that is called JSON Web Token, ID token, sorry. And we are going to actually save that into local storage. So let's do local storage dot set item JWT response.id token. And if everything worked correctly, we're going to go to the home. And this should be actually it. That's all we need. Now we just need to add this to the boot. So now, besides the home, we will also have now the sign-in page. So let's actually try it out. So no errors in the console. That's the first good sign. Let's go to sign in. And we have the login. This is the with 40%. See, very good styling. So let's try something out, like username ASDF. I click on submit. It says the username and password didn't match. That's good. That means it's calling the server. First good thing. I created already a username that exists, that it's Gonto. I know I'm creative. And if I click enter, I'm in the home. But did it work? Didn't it work? I don't know. Let's actually go here to resources, and let's check local storage. And in here, we actually now have the JSON Web Token. So if we go to jwt.io, I paste it here. You will see that this one has the username Gonto, which is me. And these two fields are issued at when was this token created, and expire when this will expire. I'm going to go over time. Sorry for the next one. And now that we have this, let's actually display it. So if we come here to the home, we can actually get the JSON Web Token. So let's say that the JWT will be local storage.getItem JWT. And let's actually display it in the view. So let's say JWT will be JWT. Now if I refresh this, boom, the JSON Web Token is shown. Now let's actually display the decoded JSON Web Token. Since it's base64 URL encoded, I can just show it. So I have imported this JWT Decode library. It's from GitHub. And it lets you decode this JSON Web Token. So let's say that the decoded JWT will exist if there is a JSON Web Token. And it will just do JWT decode of this. And that's it. So now let's receive this and show it in the view. So in the view now we're showing this JSON Web Token. Let's also show this decoded JWT in JSON format. Refresh. Now we're showing the same as JSON Web Token. So hands up who thinks that if I click on call secure API, it will work? OK. It won't work. Let's click on it. Why is it not working? Because I need to send this JSON Web Token now on every request. So let's just do that. Let's go to the home.js. And in here, let's add in headers. And let's say that the this is a hard word to write. Authorization will be better, plus this.get JWT. We're getting this JSON Web Token since we actually sent it in here as a parameter to the view. So from the view, we can do this.get JSON Web Token. So now let's refresh. Let's click on call secure API. And boom, we have the other 50 Chuck Norris phrases. That's great. So thank you. Another thing that is important is that we're in a single-page app. So now a state of being logged in doesn't exist. What does it mean to be logged in? It means having a JSON Web Token in local storage. That's all. So if we want to implement logout, all we need to do is actually delete this JSON Web Token. And that's it. Because all of our secure content is actually behind an API. And that API can only be called with a JSON Web Token. So if it's not there, we won't be able to call it. But you have to keep in mind that all the authenticated pages will still exist. The HTML and JavaScript will still exist. So let's implement this logout. If we come here to the logout button, we can say that on click, it will actually do this.logout. So let's implement it. Let's come here, and let's say that homepage.pro.type another hard word. Logout equals function of event. We're going to prevent default. And then all we need to do is just remove this value from local storage. So remove item JWT and go again to the sign-in page. And that's it. Let's try it out. We click on logout. Boom, we're in login. However, now if I go back to the root page, I can still see it. Even though there's no JSON Web Token, even though I can't call a secure API, I can still see it. And that's because, as I was saying, there is no sense of being logged in. But we can actually make it easier, even though if he goes to the source, he will be able to see this HTML. We can make it so that if there is no JSON Web Token, we can actually redirect him to the login. So let's actually do that. We have these secure routes here, and this page, if you have used Express, it's basically a middleware-based routing for the front end. So we can say in here that whenever he goes to a page that is not sign in or sign up, we can check if there's a JSON Web Token in local storage, and if there's not, redirect him to the login. So I'm not very good with regex, so that one I have to copy-paste. This regex means every page that is not sign in or sign up. Really clear, right? So in this case, we're going to get the context and next. And all we need to do now is first get the JSON Web Token. And let's actually add a try catch. So try catch E. And let's check. So if there's not a JSON Web Token, or if the JSON Web Token is not valid, that means if we can't decode it, then we're basically going to send the user to sign in. So let's say you're going to sign in. That's it. Otherwise, you can see the page that you wanted to see. So we can say you can go to whatever you were going. You can go to whatever is next. And in the catch, basically, we'll say if there's a problem, then you go to login. Why am I hiding this catch? Because this JWT decode, if there's an error and the token is malformed, it will throw an exception. So now let's actually save this. And in here, we need to require this file before everything else so that it gets executed before going to any other page. So let's require secure routes. Now, if I refresh, I'm getting sent to the login. I delete, enter, I'm getting sent to the login. Now, if I log in, Gonto, I get this here, so I can now go to sign in, and I can go back to the root, because there is actually a JSON Web Token. But this is just to make it easy for the users, if they go to an authenticated page, to go to the login, but still keep always in mind that these pages, this HTML, can still be seen by this person. Only the thing that I want to do is, we know that this is a JSON Web Token. So let's say that I'm a malicious user. So instead of, I want to pretend that I'm another person. So let's say I'm malicious. And now I have this new JSON Web Token. So I go to the website, and I actually change what is on local storage. That's it. So let's refresh the page. And now it says malicious. If I call secure API, will I be able to say that I'm malicious? Hands up who thinks that I will. Good, if you want. So now if I click on call secure API, it's saying invalid signature. And that's because the JSON Web Token that I just created is actually created with this Hey Jude signature, which is not the same as the server. I don't remember which one the server is, but it's not this one. So with this, we can see that we can't tamper this system either. So let's go back to the talk. Oh, I killed the wrong server. OK. So most of the things that we have seen today, if you want to get the slides or the GitHub project with all the steps of what I have just live coded, or if you want to get there, I also put there articles on how to do authentication with single page apps with Vanilla.js like this one, with React, Angular 1, and Angular 2. You can just go to this URL, and you will be able to see all of that content in there. I also put my Twitter handle there, so if you take a picture, you can remember me. I'm kidding. So that's basically it for me. So that's all, and thank you.